AP Calculus, section 4.2, page 4. Looking at a mean value theorem example today. Given that f of x is x cubed plus x squared minus x, for x between negative 3 and 2, this little symbol here again means is an element of. So it means x is an element of this set between negative 3 and 2. I want you to show that the mean value theorem holds. And when we say that, the mean value theorem holds, that means satisfies the initial conditions. All right, after we do that, I want you to find a C that satisfies the result of this mean value theorem. Finally, sketch a graph of f of x, the secant line, the tangent line, and that demonstrates this information. So we start first by finding the initial conditions. And the initial conditions say that f of x is continuous on that closed interval from negative 3 to 2, and that f of x is differentiable on the open interval from negative 3 to 2, and both of those are yes because f of x is a polynomial. And polynomials are smooth and continuous. Smooth being the differentiable part, no corners or cusps or vertical tangents or anything like that going on. All right, once we have the initial conditions, then we can satisfy the conclusion here. And the conclusion of the mean value theorem says f prime at C is f of b minus f of a all over b minus a. Remember that f prime of C is referring to the slope of the tangent line. And this bit here is referring to the slope of the secant line. All right, a couple of things we need to refresh your memory on, or just reiterate for you, is that this interval up here, negative 3 to 2, that is not an ordered pair. That is telling you that one of the endpoints of this particular interval is negative 3 comma something, and the other endpoint is 2 comma something. And we can figure those out if we plug negative 3 into the original function. Negative 3 cubed is negative 27. That'll be plus a 9. That's negative 18. Minus a negative 3. That's going to be a negative 15. Putting in a 2 here, that's 8. Plus 4 is 12. Minus 2 is 10. That's the interval that we're going between. So this point is, the section of the curve that we're looking at is going from negative 3 comma negative 15 up to the point 2 comma 10. All right. Once we have this interval, let's go ahead and find f prime of x. F prime of x is 3x squared plus 2x minus 1. So when we take that bit right back over here, f prime at c, that is 3c squared plus 2c minus 1. And that has to equal the slope of the secant. Well, we can follow this formula, f of b minus f of a all over b minus a, but if you know that that's slope of the secant, then just find slope between these 2 points, which would be 10 minus negative 15 over 2 minus a negative 3. And we have 3c squared plus 2c minus 1 equals 25 over 5, or just 5. To solve that equation, we need to subtract 5 from both sides, and then factor. Unfortunately, this doesn't factor, so we're going to have to do the quadratic formula. And let me show you, I happen to have this quadratic formula on my calculator. You may have it as well. It's probably in a different format than mine, but and if you need this, by all means you can ask your teacher for it. It's under program. Mine's called just quadratic. I hit enter, and for an equation in this form, ax squared plus bx plus c is 0. I just type in what a is. It's 3. Enter. What's b? 2. Enter. C is -6. Enter. Gives me 2 real solutions. And if you look up here, this is kind of flashing. That tells you that that this program is pausing. Hit enter to continue it on. And we have 2 solutions here for C. C is 1.119, and well, that's C1. And C2 is -1.786. All right. So when we look back at the directions here, find a C that satisfies the result of the mean value theorem. There are 2 of them right here, 1.119 or -1.786. Second part here is to sketch a graph of f of x. The secant line, the tangent line that demonstrates this information. So let's just jot this information down first to make sure that we have it. We know the function all the way up at the top. We need to find the secant line. And we can use one of these points right here with point slope form of a line. So we'll have y minus, I'm going to use this one, 10 equals slope. But what was the slope of the secant line? We found it right there. Slope of the secant, 5 times an x minus 2. A tangent line, y minus, well, we know we're going to have the same slope, so 5 x minus. All right, these spots are exactly where these particular x values occurred. So one of them is going to be x minus 1.119, and another one is going to be x plus 1.786. Okay, now we need to find that value right here. Isn't that value right there just this original function evaluated at 1.119? Absolutely. So what we can do is write that this is f of 1.119, and this down here would have to be then f of -1.786. And I'll show you how to type that in your calculator in a moment here. All right, so let's graph. Go to y equals, put the original function in at f of x is x cubed plus x squared minus x. And then let's put the secant here. And I'm not going to distribute that 5 through. I'm just going to let my calculator do that work for me. So let me write this as 5 parentheses x minus 2. And then we'll just add that 10 over, so plus 10. To get the tangent line, let's say I'm going to do the same thing, 5 parentheses x minus 1.119, close. And then I'm going to add over this function evaluated at 1.119. So plus, and that function is typed in at y1, so we can go y1 of 1.119. And then when we do the other tangent line, same concept. 0.005 times the quantity x plus 1.786, and then plus y1, oops, y1 at negative 1.786. There we go. Zoom 6. That might be a little tiny. No, that's pretty good. There it is. Maybe we can clean that up just a little bit. Let's see, we only need the x's to go between negative 3 and 2, so maybe I'll change this negative 5 to 5 for my x values. Y's, we need to see a negative 15 and a positive 10, so maybe just a tad bigger. How about negative 20 to 15? Secant line between those 2 points. There's one tangent, and there's the other tangent line. All right, let's go ahead and sketch this on paper so that we can see what's going on here. And no, I don't want the Y scale in there because it's going to be really out of scale. Here's the original function. Looks like it crosses between 1 and 2 here. And it's going to come up, cross down here again at 0, 0, and come back up just a little bit before 1, I believe. And it looks like that. Okay. The endpoints of our interval, we had one at 210 and another one at negative 3, negative 15. Now I'm going to have to kind of adjust the scale a little bit here so we can see it. Here is negative 3, negative 15 down here. Then the secant line connects those 2 points. Here's the secant. This purple one here is y equals f of x. And our tangent lines. One of them had an x value around 1.119, so a little bit past 1, so right over here somewhere. There's one tangent, and the other one, negative 1.786, negative. Now it's going to be off just a little bit, I think, because I had to adjust this scale down here. I didn't leave enough room on my paper to draw this. But it's reasonably close. And here's the other tangent. Thanks for tuning in. If you had any issues, that went pretty quickly here, please feel free to pause the video and replay it. Thanks.